Picture this: an entire star, a blazing sphere of gas and light millions of miles across, suddenly ripped apart, stretched like taffy, and swallowed whole by an invisible monster lurking in the darkness. This isn't science fiction. It's happening right now, somewhere out there in the cosmos, where black holes lurk, patiently waiting for their next meal. And they're just one of the countless terrors hiding in the vast expanse of space. Welcome to a universe far more dangerous, more unpredictable, and more awe-inspiring than anything you've ever imagined. We like to think of space as silent, empty, and serene, a peaceful sea of twinkling stars, but the truth, it's a battlefield, a place where forces beyond comprehension wage war, where runaway stars explode with the power of a billion suns, where invisible killers roam undetected, and where entire galaxies can be torn apart in an instant. Out there, in the infinite dark, lurk objects so destructive, so bizarre, they defy everything we think we know about physics. And today, we're counting down the 25 most dangerous things in the universe, phenomena so terrifying, they'll make you grateful for the quiet safety of our tiny cosmic neighborhood. This isn't just a list, it's a journey into the heart of the universe's darkest secrets. We'll come face to face with celestial predators, uncover forces that could erase entire solar systems in the blink of an eye, and explore anomalies so strange, scientists still struggle to explain them. Some of these cosmic killers are familiar: black holes, supernovas, rogue planets. Others, you've probably never even heard of them. But by the time we're done, you'll understand why space isn't just beautiful, it's the most dangerous place imaginable. So buckle up, we're about to dive into the chaos. Nothing in the universe embodies sheer, unstoppable destruction quite like a black hole. Imagine a place where gravity doesn't just pull, it warps reality itself, crushing everything into an inescapable void. These cosmic nightmares are born from the death throes of massive stars, collapsing under their own weight until not even light can break free. When a star several times larger than our Sun runs out of fuel, it doesn't just fade away. It implodes with such force that space and time twist around it, creating a gravitational abyss from which nothing returns. The most terrifying part, crossing the event horizon, the point of no return. Once matter slips past this invisible boundary, there's no fighting back. The laws of physics as we know them break down. Even something as simple as a human body would undergo spaghettification, stretched into an atom-thin strand by tidal forces stronger than anything in existence. But black holes aren't just lone predators lurking in the dark. At the heart of nearly every galaxy, including our own Milky Way, sits a supermassive monster. Sagittarius, a star, the colossal black hole at our galactic center, weighs in at 4 million times the mass of our Sun. Right now, it's dormant, but if something disturbed its slumber, the results would be catastrophic. Stars, planets, entire solar systems could be torn apart and devoured in a frenzy of destruction. Yet for all their horror, black holes are also one of the universe's greatest mysteries. They warp time, bend light, and might even hold the key to understanding the fabric of reality itself. But make no mistake, if you ever find yourself near one, there's no outrunning the inevitable. The universe has predators, and black holes are its most ruthless hunters. If black holes are the universe's ultimate predators, then neutron stars are nature's most extreme pressure cookers, cosmic objects so dense they defy logic. Imagine crushing the entire mass of our Sun into a sphere no bigger than Manhattan. That's the nightmare physics of a neutron star, where gravity wins in the most violent way possible. When massive stars die in supernova explosions, their cores don't always collapse into black holes. Sometimes they leave behind these unimaginably dense remnants, where matter gets squeezed so tightly that atoms cease to exist. Protons and electrons fuse into neutrons, packing billions of tons of star stuff into a single teaspoon. But the terror doesn't stop there. Some neutron stars spin hundreds of times per second, becoming pulsar celestial lighthouses blasting deadly beams of radiation across space. Get too close and those beams would strip you apart atom by atom. Even more frightening are magnetars, neutron stars with magnetic fields 1,000 trillion times stronger than Earth. Their magnetic fury is so intense it could liquefy your body from 50,000 light-years away. In 2004, a magnetar eruption halfway across our galaxy briefly outshone the full moon, releasing more energy in 1/10 of a second than our sun emits in 100,000 years. What makes these stellar zombies truly terrifying is their unpredictability. A single starquake, a crust-shaking tremor on a neutron star's surface, can unleash gamma-ray bursts capable of sterilizing entire solar systems. And because they're so small and dim, these invisible killers could be drifting through our cosmic neighborhood right now, undetected. Unlike black holes, which announce their presence by devouring everything around them, neutron stars are silent assassins, armed with gravity that could shred planets and radiation that would fry DNA in an instant. They're proof that in the universe, sometimes the deadliest things come in the smallest packages. Gamma-ray bursts are the universe's ultimate flash of destruction. Cosmic lightning strikes with the power to outshine entire galaxies in seconds. These fleeting explosions, lasting anywhere from milliseconds to a few minutes, release more energy than our sun will emit in its entire 10-billion-year lifetime. Born from the cataclysmic deaths of massive stars or the violent mergers of neutron stars, they fire twin jets of radiation at nearly the speed of light, slicing through space like celestial blowtorches. If one of these beams ever hit Earth head-on, the consequences would be unimaginable. Even from thousands of light-years away, a nearby gamma-ray burst could devastate our planet. The initial blast would deliver a lethal dose of radiation in seconds, but the real nightmare would unfold in the aftermath. The high-energy photons would rip apart nitrogen and oxygen molecules in our atmosphere, triggering a chain reaction that destroys the ozone layer. Without this protective shield, ultraviolet radiation from the sun would bombard the surface, wiping out ecosystems and plunging the planet into a mass extinction event. Some scientists believe a gamma-ray burst might explain the Ordovician extinction 450 million years ago, when over 80% of marine species vanished without warning. What makes these events so chilling is how little warning we'd have. Unlike a supernova, which gives astronomers days or weeks to observe a dying star, gamma-ray bursts arrive without preamble. In 2004, we got a terrifying glimpse of their power when a magnetar eruption, technically a soft gamma repeater, of 50,000 light-years away, briefly ionized Earth's upper atmosphere. For half a second, this dying star's death scream was brighter than the full moon, despite being halfway across the Milky Way. Had it occurred within even a fraction of that distance, the results would have been catastrophic. Yet for all their destructive potential, gamma-ray bursts also serve as cosmic lighthouses, illuminating the distant universe. Their afterglows help scientists map the structure of space-time, study the formation of early galaxies, and even hunt for elusive dark matter. But that's cold comfort when you consider the sheer randomness of their fury. Right now, somewhere in the cosmos, a star could be collapsing into oblivion, its final act a burst of energy capable of sterilizing planets light-years away. It's a reminder that the universe doesn't just harbor danger, it occasionally screams it across the void. Think of the planets in our solar system, neatly orbiting the sun in predictable paths, held in place by gravity's careful balance. Now imagine a world thrown violently from that order, hurled into the darkness to drift alone through interstellar space. These are rogue planets, cosmic nomads untethered from any star, and they're far more common and dangerous than you might realize. Most rogue planets begin like any other, born in the swirling disks of gas and dust around young stars, but gravitational tugs from sibling planets or passing stars can fling them into the void, ejecting them at speeds that send them careening across the galaxy. Some estimates suggest there could be billions of these wandering worlds in the Milky Way alone, invisible to telescopes because they emit no light of their own. Drifting in perpetual night, they're nearly impossible to detect until it's too late. The real danger lies in their unpredictability. A rogue planet passing through a star system could disrupt delicate orbital balances, sending planets spiraling into chaos. Picture a world several times the mass of Jupiter barreling through our solar system. Its gravity would act like a wrecking ball, scattering asteroids from the belt, tugging Neptune and Uranus from their orbits, and potentially even nudging Earth into a path that's either lethally close to the Sun or flung into the frozen outskirts of space. Even a near miss could destabilize our climate, triggering ice ages or runaway greenhouse effects that would make the planet uninhabitable. But there's another, eerier possibility lurking beneath their frozen surfaces. Some rogue planets may harbor vast subsurface oceans, kept liquid by geothermal heat or the crushing pressure of thick ice shells. Cut off from the warmth of a star, these hidden seas could still host extremophile life, organisms thriving in darkness under miles of ice, just like those in Earth's deepest ocean trenches. If life exists in these isolated abysses, it would be utterly alien, evolving without sunlight or photosynthesis in conditions we can barely imagine. The scariest part, we'd never see them coming. Unlike asteroids or comets, rogue planets are dark, cold, and nearly undetectable until they're already disrupting the gravitational fabric of a star system. Right now, one could be drifting toward us, silent and unseen. It's a cosmic game of chance, and the stakes couldn't be higher. The universe doesn't just harbor dangers we can see, it's full of invisible threats wandering in the dark. Some stars don't just drift peacefully through the galaxy. They're cosmic bullets hurtling through space at speeds that defy reason. Hypervelocity stars are stellar outlaws ejected from their home systems with such force. They travel at millions of miles per hour, fast enough to escape the Milky Way entirely. These runaway stars don't just leave their neighborhoods behind. They become celestial wrecking balls capable of unraveling the delicate gravitational webs that hold solar systems together. The most terrifying aspect, their speed isn't born from natural stellar evolution. These stars are victims of cosmic violence catapulted into the void by the gravitational slingshots of supermassive black holes or the chaotic aftermath of galactic collisions. Picture a binary star system, two stars orbiting each other, wandering too close to the black hole at the galaxy's center. The black hole's immense gravity tears them apart. One star gets captured while the other is flung outward at unimaginable speeds, a solitary projectile racing through the darkness. Now imagine one of these stellar missiles passing near our solar system. Even at a distance of a few light years, its gravitational influence could be catastrophic. A hypervelocity star wouldn't need to collide with us to cause devastation. Its sheer mass and speed would act like a gravitational plow, disturbing the orbits of planets and flinging asteroids from the Kuiper belt inward in a deadly hailstorm. Earth's stable, life-friendly orbit gone. The gas giants, our solar system's gravitational anchors, knocked out of alignment, sending smaller planets spiraling into the sun or ejected into the frozen depths of interstellar space. The scariest part, we might not see it coming until it's too late. Hypervelocity stars are rare but not impossible. In 2005, astronomers discovered one, dubbed He04375439, racing away from the Milky Way at over 1.5 million miles per hour. If a star like that crossed paths with our corner of the galaxy, the havoc would be unstoppable. There would be no time to react, no way to deflect it. The universe doesn't care about fairness. It operates on scales of energy and momentum we can scarcely comprehend. Yet hypervelocity stars also tell a story of cosmic survival. Some may carry planets with them, frozen worlds ripped from their original orbits but still clinging to their exiled suns. Others might even harbor life, organisms adapted to the eternal twilight of a star wandering between galaxies. But for us, on our fragile little planet, they're a reminder that the universe is anything but static. Out there, in the darkness, lurk forces that could rewrite our fate in an instant. No warnings, no second chances. The galaxy giveth, and the galaxy taketh away. Quasars are the universe's ultimate cosmic blowtorches, blindingly bright beacons of destruction lurking in the distant reaches of space. These celestial monsters are actually supermassive black holes in disguise, but not the quiet, lurking kind we've talked about before. These are black holes that have gone berserk, gorging themselves on so much matter that the infalling gas and dust glow brighter than an entire galaxy of stars. The energy released is so intense, it can outshine 1 trillion suns, making quasars some of the most luminous objects in existence. But their true terror lies in what they unleash into the cosmos. As matter spirals into the black hole's maw at nearly light speed, it doesn't just vanish quietly. Some of it gets twisted and funneled into twin jets of superheated plasma, screaming outward at relativistic speeds. These jets stretch for hundreds of thousands of light years, carving through interstellar space like cosmic flamethrowers. Anything caught in their path of planets, stars, even whole star systems would be bathed in deadly radiation, sterilized in an instant. A quasar's fury doesn't just kill, it scours galaxies clean of life, leaving behind nothing but cold, dead husks. What makes them especially chilling is their history. The early universe was packed with these monsters. Billions of years ago, when galaxies were younger and gas was more plentiful, quasars were far more common and far more violent. They likely played a major role in shaping the evolution of galaxies, their deadly jets regulating star formation by either triggering stellar birth or snuffing it out entirely. Some researchers even suspect that quasars may have prevented life from arising too early in the cosmos, their radiation purging fledgling planets before complex organisms could take hold. Yet for all their destructive power, quasars also serve as cosmic lighthouses. Because they shine so brightly, astronomers use them to map the distant universe, studying the structure of space-time and the distribution of matter billions of light years away. The light from these ancient beacons has traveled so far that it gives us a glimpse into the universe's youth, a time of chaos and violence that shaped everything we see today. But don't let their distance lull you into a false sense of security. While the nearest known quasar is hundreds of millions of light years away, their existence proves that supermassive black holes, like the one lurking silently in our own Milky Way, can awaken from their slumber. If fresh gas or a wayward star were to plunge into Sagittarius, a star, our galactic center could, in theory, ignite into a quasar. The results would be apocalyptic. The radiation alone would strip away our atmosphere, and the jets, if aligned with Earth, would scour our planet down to the bedrock. Quasars remind us that the universe's most violent forces aren't always hidden in the shadows. Sometimes they shine with unbearable brilliance, a warning written across the cosmos in light and fire. They're proof that even the brightest things in the sky can be the deadliest. Dark matter is the universe's greatest unsolved mystery, an invisible, intangible substance weaving through everything you see, feel, and know. It doesn't emit light, reflect it, or interact with ordinary matter in any way we can detect. Yet it's everywhere, outweighing all the stars, planets, and galaxies combined. Imagine a ghostly ocean filling the cosmos, its currents sculpting the universe on scales we can barely comprehend. Without dark matter, galaxies would fly apart, cosmic structures wouldn't exist, and the night sky would be empty. But for all its importance, dark matter remains elusive, detectable only by the gravitational shadows it casts on the visible universe. Now here's where things get unsettling. Some theories suggest dark matter isn't just a diffuse fog. It might clump together into dense, asteroid-sized masses called macros. These hypothetical objects could be hurtling through space right now, invisible and utterly silent. If one passed through Earth, the consequences would be catastrophic. Unlike familiar matter, macros wouldn't slow down when hitting our planet. They'd slice straight through, their immense gravity compressing everything in their path. The friction alone would superheat the rock around them, potentially triggering earthquakes or volcanic eruptions. Some researchers speculate that dark matter interactions could explain mysterious extinction events in Earth's past. Sudden, unexplained die-offs with no clear geological or astronomical cause. What makes this especially chilling is how powerless we'd be. You can't shield against something you can't see or stop an object that doesn't obey the usual rules of physics. A macro wouldn't leave a crater or a trail, just devastation in its wake as it exited the other side of the planet. The only evidence might be a spike in underground temperatures or a wave of seismic activity with no obvious origin. And because dark matter permeates the galaxy, these events could happen at any time with no warning. Yet for all their destructive potential, macros are still just one possibility in a sea of theories. Other dark matter candidates like WIMP or actions are far less dramatic, interacting so weakly with normal matter that they'd pass through you trillions of times every second without a trace. But that's the real horror of dark matter, we don't know. It could be a harmless cosmic backdrop, or it could harbor forces capable of rewriting our understanding of reality itself. Every experiment, every detector buried deep underground brings us closer to an answer, and when we find it, we might finally understand whether the universe's hidden skeleton is its greatest secret or its silent threat. If dark matter is the universe's invisible scaffolding, dark energy is its silent demolition crew, a mysterious force pushing space itself apart at an ever-increasing rate. Unlike gravity, which pulls matter together, dark energy works in opposition, driving galaxies away from each other with inexplicable strength. It makes up nearly 70% of the universe's total energy budget, yet we know almost nothing about it. This isn't just some subtle cosmic quirk. It's the dominant force shaping the fate of everything that exists. The horror of dark energy lies in its relentlessness. Since the Big Bang, the universe has been expanding, but for billions of years, gravity fought back, slowing that expansion down. Then, around 5 billion years ago, something changed. Dark energy took over, and the expansion began accelerating. Galaxies started fleeing from one another faster and faster, as if space itself were stretching at an ever-quickening pace. Today, distant galaxies are vanishing over the cosmic horizon, their light stretched beyond detection as the void between us grows insurmountable. This acceleration leads to the most chilling doomsday scenario of all, the Big Rip. Imagine dark energy growing stronger over time, its repulsive force overpowering not just galaxies but the very fabric of reality. First, galaxy clusters would be torn apart. Then individual galaxies, stars would be ripped from their orbits, planets flung into the void. In the final moments, even atoms would be shredded, protons and electrons torn apart as the space between them expands faster than the forces holding them together. The universe wouldn't end with a collapse or a freeze, but with a violent, unstoppable unraveling of existence itself. The timeline for this catastrophe. Trillions of years in the future, so distant it feels almost abstract, but the inevitability is what unsettles scientists. Dark energy's strength appears constant, but if it increases even slightly over cosmic timescales, the Big Rip becomes unavoidable. Some theories suggest it already is. The acceleration we observe today might just be the beginning of a runaway effect that grows exponentially, like a snowball tumbling downhill until it becomes an avalanche. Yet dark energy isn't just a grim reaper lurking in the far future. It's reshaping the universe right now. In a few billion years, the Milky Way will merge with Andromeda, but after that, no new galaxies will ever collide again. The space between them will grow too vast too quickly. Future civilizations, if they arise, will look up at an empty sky, their local group of galaxies the only islands left in an endless, expanding void. The universe won't just die, it will fade into isolation, each surviving fragment cut off from the rest by an impassable gulf of nothingness. What makes dark energy so unnerving is its complete indifference. It doesn't devour like black holes or incinerate like supernova. It simply stretches silently and without malice until reality itself comes undone. We're left staring into the abyss, realizing the universe's greatest threat isn't a collision or an explosion, it's the emptiness between us, growing wider every second. Antimatter sounds like something ripped straight from science fiction, a mirror version of reality where particles have opposite charges, ready to obliterate normal matter in a flash of pure energy. But this isn't fiction, it's real, and it's lurking out there in the cosmos. When matter and antimatter meet, they don't just react, they annihilate each other completely, converting their combined mass into energy with 100% efficiency. A single gram of antimatter colliding with a gram of matter would unleash an explosion rivaling a nuclear bomb, all from a speck smaller than a raisin. Now imagine an entire cloud of this stuff drifting through space. These antimatter regions are rare, but they exist. They form in extreme environments, near pulsars, in the aftermath of supernova, or in the chaotic jets erupting from black holes. In these violent corners of the universe, particles collide with such force that they literally create their own opposites. Occasionally, pockets of antimatter escape, floating like cosmic landmines through the galaxy. If a starship, or worse, a planet blundered into one of these clouds, the results would be apocalyptic. The annihilation would cascade through the cloud, releasing energy surpassing every nuclear weapon ever built, all in a fraction of a second. But here's the twist: antimatter isn't just some distant threat, it's closer than you think. In 2011, the Fermi Gamma Ray Space Telescope discovered something startling: belts of antimatter particles trapped in Earth's magnetic field. These particles, mostly antiprotons, are thought to form when cosmic rays slam into our atmosphere, creating fleeting bursts of antimatter that get caught in the planet's magnetosphere. For now, these belts are diffuse, posing no real danger, but their existence proves that antimatter isn't confined to deep space. It's here, woven into the fabric of our own cosmic backyard. The real enigma is why the universe isn't filled with antimatter. According to physics, the Big Bang should have created equal amounts of matter and antimatter. Yet somehow matter won out. Every star, every planet, every atom in your body exists because of that mysterious imbalance. Somewhere in the early universe, a cosmic tipping point occurred, and scientists still don't know why. That missing antimatter, it might still be out there, hidden in vast structures we've yet to detect. What makes antimatter so unnerving isn't just its destructive potential, it's the unanswered questions it represents. A single misstep in nature's design, and our universe could have been nothing but light and radiation, with no planets, no stars, no life. Instead, we live in a world where antimatter is the exception, not the rule. But exceptions can be deadly. Whether it's a rogue cloud drifting between the stars or a man-made accident in a particle collider, antimatter remains one of the universe's most perfectly efficient killers, a shadow version of reality, waiting to erase itself in a blaze of annihilation. 66 million years ago, a cosmic bullet changed everything. A rock 6 miles wide, moving at 40,000 miles per hour, slammed into what's now the Yucatan Peninsula. The impact released energy equivalent to billions of atomic bombs, igniting wildfires across continents, choking the skies with ash, and wiping out 75% of Earth's species, including the dinosaurs. This wasn't a fluke. The universe has a long memory for violence, and asteroids like Chicxulub are proof that the greatest threats don't always lurk in deep space. Sometimes they're hiding in plain sight, drifting silently through our solar system. Right now, over 30,000 near-Earth objects are being tracked, asteroids and comets whose orbits bring them uncomfortably close to our planet. Two of them, Bennu and Apophis, have earned special attention from astronomers. Bennu, a carbon-rich asteroid the size of the Empire State Building, has a 1 in 2,700 chance of hitting Earth in the late 22nd century. Those might sound like reassuring odds, but in cosmic terms, that's alarmingly high. Apophis is even more notorious. When first discovered in 2004, scientists calculated a terrifying 1 in 37 chance it would strike Earth in 2029. Updated observations ruled that out, but it'll still skim past us in 2029 at just 19,000 miles away, closer than some satellites. One slight gravitational nudge from another asteroid, and its next visit could be far less friendly. The terrifying truth is that impacts aren't rare, they're inevitable. Earth's surface is scarred with hundreds of craters, evidence of a relentless bombardment spanning billions of years. In 1908, the Tunguska event flattened 800 square miles of Siberian forest with the force of a 10-megaton explosion, all from an asteroid barely 60 meters wide. If that had hit a major city today, millions would have vanished in an instant. And unlike black holes or gamma-ray bursts, asteroid strikes aren't hypothetical doomsday scenarios. They've happened before and they will happen again, but here's the good news. For the first time in history, we're not helpless. NASA's DART mission proved we can fight back. In 2022, a refrigerator-sized spacecraft deliberately crashed into the asteroid Dimorphos at 14,000 miles per hour, not to destroy it but to nudge its orbit. The test was a resounding success, shortening Dimorphos' orbit by 32 minutes. It's the first step toward planetary defense, turning science fiction into reality. Future missions could deploy gravity tractors, ion beams, or even nuclear detonations to redirect incoming threats. The real challenge isn't the technology, it's time. Unlike the slow creep of dark energy or the distant threat of hypervelocity stars, asteroids operate on human timescales. A city killer could appear in telescope data tomorrow with just weeks or months until impact. That's why projects like the Vera Rubin Observatory are critical, scanning the sky nightly for faint, fast-moving dots that might spell trouble. Early warning means the difference between deflection and disaster. So while Bennu and Apophis dominate headlines, the greater danger might be the thousands of unknown asteroids still lurking in the darkness. The Chicxulub impact reset the course of life on Earth. The next one could determine whether humanity joins the dinosaurs or becomes the first species to dodge a cosmic extinction bullet. The universe throws rocks. Our job is to make sure we're not in the way. Comets are the universe's celestial paradox, glittering visitors with tails of shimmering dust and ice, yet hiding the potential for catastrophe beneath their beauty. For centuries, humans have gazed in awe at these cosmic wanderers, interpreting them as omens, messengers, or even harbingers of doom. But in 2013, we got a brutal reminder of their destructive power when a relatively small object, unrelated to comets but similar in unpredictability, exploded over Chelyabinsk, Russia. The fireball, brighter than the sun, shattered windows across 6 cities, injured over 1,500 people, and released 30 times the energy of the Hiroshima bomb, all from a rock just 20 meters wide. If something that small could cause such chaos, imagine the devastation of a full-fledged comet impact. The real threat comes from long-period comets, those that take centuries or even millennia to complete a single orbit around the Sun. These icy bodies originate in the distant Oort cloud, a vast spherical shell of debris encircling our solar system far beyond Pluto. Unlike asteroids whose orbits we can map and predict, these comets appear almost out of nowhere, streaking in from the cosmic dark at breakneck speeds. By the time we spot one, it might already be too late. Their trajectories are often steep, their approach angles erratic. Some could be barreling toward us right now, undetected, cloaked in the infinite blackness of space. What makes them especially deadly is their composition. Comets aren't just frozen chunks of ice, they're loaded with volatile gases, organic material, and dust, all packed into a structure more fragile than concrete. When they collide with Earth's atmosphere, they don't just burn up cleanly. They can fragment violently, triggering an airburst, a mid-air explosion that amplifies their destructive power. The Tunguska event of 1908, which flattened an area the size of Tokyo, was likely caused by a comet fragment detonating 5 miles above the ground. No crater, just pure concussive force radiating outward like an invisible fist. But here's the twist: even if a comet doesn't hit us, its dust trail can still wreak havoc. When Earth passes through the debris left behind by comets like Halley or Swift-Tuttle, we get meteor showers, harmless, dazzling light shows. But dense debris fields from larger comets could bombard our atmosphere with thousands of tiny particles traveling at hypersonic speeds. Individually, they're harmless, but en masse, they might pose risks to satellites, spacecraft, or even the ozone layer. And if a comet's nucleus itself disintegrated near Earth, the resulting dust cloud could linger for years, scattering sunlight and plunging the planet into a temporary winter. Crops would fail, ecosystems would collapse. The very thing that makes comets beautiful, their luminous, spreading tails, could become a slow-motion disaster. Yet for all their danger, comets also hold secrets to our origins. They're cosmic time capsules, preserving pristine material from the solar system's birth 4.5 billion years ago. Missions like Rosetta have landed on their surfaces, uncovering organic molecules that hint at the building blocks of life. In a way, comets might have delivered the ingredients for life to Earth, only to threaten it later with the same icy fists that once nourished it. The chilling reality is that while we've gotten better at tracking asteroids, comets remain the wild cards of our solar system. A city killer could arrive with just months or weeks of warning. And unlike an asteroid, which might give us time to deflect it, a comet's speed and unpredictability could leave us with no options at all. The universe doesn't care about fairness. It sends beauty and destruction in the same package, leaving us to marvel at the spectacle until the moment it's too late to look away. Wolf-Rayet stars are cosmic time bombs, massive, unstable behemoths burning through their final acts with terrifying speed. These aren't your average stars. Imagine a sun 20 times more massive than our own, but one so volatile, it's literally tearing itself apart, ejecting entire Earth masses of material into space every year. Their surfaces rage with hurricane-force stellar winds, blasting outward at over 6 million miles per hour, carrying enough energy to strip away any atmosphere from a nearby planet in seconds. Take WR-104, for example, a binary system 7,800 light-years away, where one of these monsters spins like a furious top, flinging spiral arms of superheated gas into the void. Some astronomers suspect it's poised to go supernova, and if its poles are pointed anywhere near us, the resulting gamma-ray burst could be catastrophic. A direct hit would bathe our planet in radiation capable of shredding the ozone layer for years, unleashing deadly ultraviolet rays and triggering a mass extinction. The debate over its alignment keeps scientists up at night because with Wolf-Rayet stars, even their deaths are unpredictable. What makes these stars so dangerous isn't just their eventual explosions, it's the chaos they sow while still alive. Their winds carry heavy elements like carbon and oxygen, but also a relentless storm of high-energy particles. Any planets orbiting within dozens of light-years would be scoured clean by the onslaught, their surfaces sterilized by the ceaseless barrage. And because Wolf-Rayet stars burn so hot and so fast, their lifespans are shockingly short, just a few million years compared to our Sun's 10 billion. They're the rock stars of the cosmos, living fast, dying young, and leaving behind destruction in their wake. Yet for all their fury, Wolf-Rayet stars also serve as cosmic forges. The elements they spew into space, silicon, iron, even gold, are the building blocks of future planets and life. Their deaths seed the galaxy with the raw materials for new solar systems, proving once again that the universe's most destructive forces are also its most creative. But that's cold comfort if you're caught in the blast radius. The unsettling truth is that we might not see the worst coming. Unlike an asteroid or comet, which we can track for decades, a Wolf-Rayet star's supernova could arrive with little warning. Just a sudden, blinding flash in the sky, followed by irreversible devastation. And with hundreds of these ticking time bombs scattered across the galaxy, the question isn't if one will explode, it's when, and whether we'll be lucky enough to be out of the line of fire when it does. White dwarfs are the quiet corpses of stars' stellar remnants so dense, a teaspoon of their material would weigh as much as an elephant on Earth. These smoldering embers were once stars like our Sun, but after exhausting their nuclear fuel, they collapsed into Earth-sized spheres of degenerate matter, glowing faintly with leftover heat. For billions of years, they cool and fade, seemingly harmless, but beneath that calm exterior lies a terrifying potential, the capacity to detonate with the force of 1 billion nuclear bombs. The trigger, a cosmic heist. If a white dwarf orbits close enough to a companion star, especially a red giant, it can siphon off material, slowly accumulating mass like a thief hoarding stolen riches. For a while, this theft goes unnoticed. The stolen gas piles onto the white dwarf's surface, compressing under its immense gravity until the pressure becomes unbearable. Then, in a fraction of a second, the temperature skyrockets to 100 million degrees, igniting runaway nuclear fusion. The entire white dwarf detonates in a cataclysm known as a Type I supernova, outshining entire galaxies for weeks. These explosions aren't just spectacular, they're eerily uniform. Because white dwarfs detonate at roughly the same mass each time, their brightness is predictable, making them cosmic standard candles for measuring vast distances across the universe. But that uniformity also means their destructive potential is perfectly calculable. A Type I supernova within 30 light-years of Earth would bombard our planet with enough gamma rays and X-rays to strip away the ozone layer, triggering a cascade of deadly ultraviolet radiation and climate collapse. The last time this likely happened, around 2.6 million years ago, when a nearby supernova may have contributed to a minor extinction event, peppering Earth with radioactive isotopes still detectable in ocean crust today. Right now, the closest known candidate for such a catastrophe is Pegasi, a binary system 150 light-years away. Its white dwarf is steadily feeding on its sun-like companion, but astronomers estimate it won't reach critical mass for another 2 billion years, and by then, orbital changes may have pushed the stars apart, preventing disaster. Still, Pegasi is a reminder that our galactic neighborhood isn't entirely safe. Other white dwarfs could be lurking in undetected binaries, quietly gorging themselves until they reach their lethal limit. What makes these stellar time bombs especially unsettling is their stealth. Unlike massive stars that signal their impending doom with dramatic expansions or violent eruptions, white dwarfs betray no visible warning until it's too late. One day, they're cold, dead relics. The next, they're the brightest objects in the sky, heralding devastation light-years away. Fortunately, the odds of a nearby detonation in our lifetime are vanishingly small. But the universe has a way of reminding us, even in death, stars hold the power to create or destroy. And sometimes, all it takes is a little stolen mass to tip the scales from ember to apocalypse. Brown dwarfs are the cosmic in-betweeners, too massive to be planets, yet too small to ignite the nuclear fires that make true stars shine. These failed stars languish in obscurity, trapped in perpetual twilight, never reaching the temperatures needed to fuse hydrogen. Some are barely warmer than a cup of coffee, emitting only faint infrared glows as they drift through the galaxy, but don't let their dimness fool you. What they lack in light, they make up for in gravitational menace. Imagine a brown dwarf passing through our solar system. Even one just a few times heavier than Jupiter could wreak havoc without ever being seen. Unlike stars, which announce their presence with blinding radiation, brown dwarfs are stealthy, their weak heat signatures easily lost in the cosmic background. By the time telescopes spotted one, it might already be too close, its gravity tugging at the delicate balance of planetary orbits. The outer planets would be the first to spiral out of alignment, their paths distorted like marbles rolling across a warped table. Neptune and Uranus could be flung into erratic new trajectories, while the asteroid belt might erupt into chaos, sending deadly projectiles hurtling inward. Earth's stable, life-friendly orbit gone, reshaped by an invisible intruder. Then there are the rogue brown dwarfs, those exiled from their birth systems, wandering the galactic void alone. These nomads are practically ghosts, nearly impossible to detect until they're disturbingly close. In 2012, astronomers found one of these drifters just 7 light-years away, closer than many known stars. If a rogue brown dwarf slipped into our neighborhood, its gravity could strip comets from the Oort cloud, hurling them toward the inner solar system in a deadly hailstorm. The worst part, unlike asteroids or comets, we'd have almost no warning. These dark wanderers don't reflect sunlight or leave glowing trails. They move unseen, their presence betrayed only by the havoc they leave behind. Yet brown dwarfs aren't just agents of destruction. They're cosmic laboratories offering clues about the blurry line between planets and stars. Some even harbor turbulent atmospheres with storms larger than Earth and clouds of molten iron or salt. A few might host moons, icy worlds with subsurface oceans, hidden beneath layers of rock and frozen gas. If life exists in these shadowy realms, it would cling to geothermal vents, thriving in eternal darkness. But for all their mystery, brown dwarfs serve as a chilling reminder. The universe doesn't need bright, blazing stars to upend our existence. Sometimes the greatest threats are the ones we can't see, silent, patient, and drifting ever closer through the dark. Interstellar gas clouds drift through the galaxy like silent titans, vast, swirling seas of hydrogen, helium, and complex molecules stretching hundreds of light-years across. At first glance, they're celestial masterpieces, their delicate filaments illuminated by newborn stars. The Taurus molecular cloud, just 450 light-years away, is one such marvel, a stellar nursery where suns are born amidst veils of cosmic dust. But don't let their beauty fool you. Hidden within these ethereal structures lurks a danger far more insidious than any asteroid or rogue planet: the power to unravel our solar system's fragile defenses. Picture the heliosphere, a protective bubble of charged particles streaming from the sun, shielding Earth from 60% of the deadly cosmic rays hurtling through the galaxy. This invisible force field is our first line of defense against interstellar radiation, a barrier so vital that without it, our atmosphere would be bombarded with particles capable of shredding DNA and mutating life at its core. Now imagine a molecular cloud, dense and cold, drifting inexorably toward us. As the solar system plunges into its depths, the heliosphere would collapse under the pressure, compressed like a balloon squeezed in a fist. Cosmic rays that once ricocheted harmlessly away would now flood inward, piercing our planet's magnetic field with ease. The result, a radiation storm lasting thousands of years, spiking cancer rates, crippling ecosystems, and potentially triggering a global ice age as ionized particles seed thick cloud cover, reflecting sunlight back into space. This isn't just theoretical. Geological evidence suggests Earth may have endured such an event 2 to 3 million years ago, when our solar system passed through the local interstellar cloud, a wispy filament of gas far less dense than the Taurus complex. Sediment layers from that period show a sudden influx of radioactive iron-60, an isotope forged in distant supernova and carried here by cosmic rays. If a diffuse cloud left its mark, a full-fledged molecular cloud could rewrite the fate of civilization. The chilling reality is that these clouds are everywhere. The Milky Way is riddled with them, and their motion is chaotic, governed by the galaxy's turbulent magnetic fields and gravitational tides. Astronomers estimate the solar system crosses a major cloud every few 100 million years. a cosmic game of Russian roulette where the next encounter could come tomorrow or in 50 million years. And unlike asteroids or comets, we'd have almost no warning. These clouds don't glow like stars or reflect sunlight like planets. They're stealthy, detectable only by the faintest radio emissions or the shadow they cast against distant starlight. By the time we noticed one approaching, it might already be too late. Yet within this threat lies an ironic twist. These same clouds are the raw material for life. Every atom in your body, the oxygen in your lungs, the carbon in your cells was once part of a molecular cloud, forged in the hearts of stars and scattered across the cosmos by explosions just like the ones whose radiation we fear. They're both creators and destroyers, the universe's way of balancing birth and extinction on scales we can barely comprehend. So while we gaze up at the Taurus complex and marvel at its star-forming splendor, remember, the stuff of life can also be the herald of chaos. And somewhere out there, another cloud drifts, waiting for its moment to rewrite the story of our world. Vacuum decay isn't just science fiction, it's a theoretical apocalypse so absolute it would erase the universe as we know it in the blink of an eye. Picture the fabric of reality like a fragile hilltop, balancing precariously in a false vacuum state. For now, everything seems stable. Particles interact, gravity holds, light travels at its constant speed. But beneath this apparent stability lurks a terrifying possibility that our universe isn't in its true lowest energy state. Somewhere out there, a single quantum fluctuation could tip the scales, creating a microscopic bubble of true vacuum, where the laws of physics as we understand them cease to exist. This bubble wouldn't just sit there, it would expand at the speed of light, a spherical wave of annihilation rewriting the fundamental constants of nature in its wake. Inside this new reality, atoms might not hold together. The forces binding protons and electrons could dissolve. Even the speed of light itself could change, rendering every law of physics obsolete. One moment you're here, the next the universe around you, and you along with it transforms into something unrecognizable. No explosion, no warning, just an invisible curtain of destruction sweeping across the cosmos, leaving no chance for escape or survival. The most chilling part, we wouldn't see it coming. If vacuum decay began in a distant galaxy, the first sign would be the wave itself hitting us. By the time astronomers spotted strange distortions in the light of faraway stars, it would already be too late. The edge of the bubble would arrive at the exact same moment as the light warning us of its approach. There'd be no time to react, no way to fight back. The universe itself would change its rules mid-sentence, and everything we've ever known would vanish into a new, alien reality where life as we understand it might be impossible. Yet for all its horror, vacuum decay remains deeply hypothetical. The standard model of particle physics suggests our vacuum is stable, and the energy barrier separating us from true vacuum is likely insurmountable. But science evolves. New discoveries like the Higgs boson's unsettlingly light mass hint that our universe might be metastable, clinging to stability rather than sitting at the absolute lowest energy state. It's like balancing a pencil on its tip. It could stay upright indefinitely, but the slightest nudge sends it crashing down. The irony is almost poetic. The same quantum mechanics that allow particles to pop in and out of existence, the same laws that make stars shine and life possible, could also harbor the seeds of total cosmic annihilation. Vacuum decay isn't just about destruction, it's a reminder of how little we truly understand about the universe's deepest rules. For now, the odds are overwhelmingly in our favor. But in the grand tapestry of cosmic threats, it stands alone as the most absolute, the most final, and the most indifferent. The universe doesn't need black holes or gamma-ray bursts to end everything. Sometimes all it takes is a tiny bubble and the courage to acknowledge it might exist. Primordial black holes sound like something straight out of a physicist's nightmare, tiny, ancient, and invisible remnants of the Big Bang itself. Unlike the monstrous black holes born from dying stars, These hypothetical objects could be as small as a pinhead or as massive as a mountain, forged in the chaos of the universe's first microseconds. Picture the infant cosmos, a seething cauldron of energy so dense that random fluctuations in density could have collapsed into black holes spontaneously. No star death required, just pure primordial violence frozen in time and left to wander the cosmos for billions of years. Now imagine one of these ghosts drifting through our solar system. Even a primordial black hole no larger than an atom would pack the mass of a skyscraper, its gravity warping space around it like a lead weight on a trampoline. If it passed through Earth, the effects would be grotesquely subtle at first, a whisper of distortion as atoms in its path were stretched and compressed. But as it plowed deeper, seismic ripples would follow in its wake, triggering earthquakes along a perfectly straight, impossibly narrow path. Underground detectors might register strange tremors with no tectonic explanation, while satellites overhead could spot bizarre gravitational lensing effects distorting starlight for a fraction of a second. The true horror, though, would come if it slowed enough to linger inside our planet. Swallowing atoms one by one, it could grow exponentially, sinking toward Earth's core like a stone through water, its appetite increasing with every gram consumed. The most unsettling part, we wouldn't know it was there until it was too late. Primordial black holes don't emit Hawking radiation unless they're incredibly small, small enough to evaporate in a flash of gamma rays long before reaching us. Larger ones are effectively invisible, detectable only by their gravitational fingerprints. Some theories suggest they could be hiding in plain sight, masquerading as dark matter. If that's true, our galaxy might be swimming with them, a sea of ancient predators lurking in the dark. Yet for all their destructive potential, these cosmic relics could also solve some of the universe's greatest mysteries. Their existence might explain dark matter's gravitational effects without invoking exotic particles. They could even be the seeds of supermassive black holes, growing over eons into the monsters we now see at the centers of galaxies. The irony is delicious. The same objects that might one day unravel our planet could also hold the keys to understanding the universe's deepest secrets. The catch, of course, is that we've never actually found one. Despite decades of searching, scanning for gamma-ray bursts from evaporating black holes, hunting for gravitational microlensing events in distant stars, not a single primordial black hole has been confirmed. They remain ghosts in the equations, a tantalizing what-if hovering at the edge of physics. But absence of evidence isn't evidence of absence. Somewhere out there, in the vast gulf between galaxies, these ancient time capsules might still drift, silent and patient, waiting for the moment their paths cross ours. And if they do, we'll learn the hard way that the universe's deadliest terrors don't always come with warning labels. Blazars are the universe's ultimate cosmic snipers, active galaxies with supermassive black holes at their cores, firing jets of plasma and radiation directly at Earth with terrifying precision. Unlike their more polite galactic cousins, which aim their energy beams harmlessly into empty space, blazars have their barrels pointed right at us, flooding our planet with some of the highest energy radiation ever observed. These aren't just distant fireworks, they're celestial particle accelerators, channeling the power of billions of suns into beams so intense, they can travel billions of light years without dissipating. Take Markarian 501, a blazar 456 million light years away that sent astronomers into a frenzy in 1997. Over the course of a single night, its gamma-ray output flared to double its normal intensity, bathing Earth in a surge of radiation that would have been lethal, if not for the sheer distance protecting us. Had this outburst occurred within even a fraction of that range, the jet's energy could have stripped our atmosphere, irradiating the surface and triggering a mass extinction. Instead, the only casualties were a few overworked telescopes, pushed to their limits trying to capture the event. What makes blazars uniquely terrifying is their geometry. Most active galactic nuclei, like quasars, shoot their jets at random angles across the cosmos. But blazars are special because their jets align almost perfectly with our line of sight, amplifying their apparent brightness and turning them into cosmic blowtorches aimed at our planet. The physics behind these jets is monstrous. Particles accelerated to nearly light speed, twisted into spirals by magnetic fields stronger than anything we could replicate on Earth, and then hurled into the void with enough force to punch through entire galaxy clusters. The real kicker, we're sitting in the crosshairs of dozens of these monsters right now. While Markarian 501's flare was dramatic, it's far from the most powerful blazar on record. In 2012, Picas 045423 briefly outshone all other gamma-ray sources in the sky, its jet packing the energy of 10 trillion electron volts, enough to make even the most hardened astrophysicists pause. And because these jets travel at light speed, we'd have zero warning before the radiation hit. No time to prepare, no chance to deflect. Just an invisible storm of particles rewriting the rules of biology and chemistry across the planet. Yet for all their destructive potential, blazars also serve as cosmic laboratories, giving us front-row seats to physics at its most extreme. By studying their light curves and spectra, scientists have uncovered clues about black hole spin, the nature of dark matter, and even the structure of space-time itself. They're reminders that the universe doesn't just harbor danger, it occasionally uses that danger to illuminate its deepest mysteries. So while we should be grateful for the vast gulfs of space shielding us from these gamma-ray Gatling guns, we should also appreciate their role in stretching our understanding of what's possible. After all, in a cosmos where even light can be weaponized, knowledge might be the best defense we have. Our sun may seem like a steady, reliable neighbor, a warm, glowing beacon in the sky. But beneath that placid surface rages a cauldron of plasma and magnetic fury, capable of unleashing storms so violent they can reach across 93 million miles of space and slap civilization back into the Dark Ages. These aren't distant cosmic threats, they're homegrown disasters, and we've already had a terrifying preview of what they can do. In 1859, a solar storm of unprecedented ferocity struck Earth. The Carrington event, named after astronomer Richard Carrington, who witnessed the flare erupting from the sun's surface, unleashed a coronal mass ejection so powerful it set telegraph offices on fire. Operators received shocks through their equipment even after disconnecting the power. Auroras, normally confined to polar regions, blazed as far south as Cuba, so bright they woke people who mistook the crimson skies for dawn. And that was before electricity powered, well, everything. A similar storm today wouldn't just fry a few telegraph wires, it would trigger a global catastrophe. Modern power grids, stretched thin by decades of soaring demand, are far more vulnerable than their 19th century predecessors. The surge of charged particles from a Carrington-level solar flare would induce devastating currents in high-voltage transformers, the massive, hard-to-replace backbones of electrical infrastructure. One study estimates a single night of geomagnetic chaos could knock out power for 40 million people in the U.S. alone, with some regions blacked out for years. The cost, up to $2 trillion in the first year, as food spoils, hospitals go dark, and supply chains collapse, but the real nightmare unfolds in orbit. Satellites, our eyes in the sky, our global communication network, our GPS, would take the brunt of the storm's fury. Radiation fries delicate electronics, while the swelling atmosphere drags low Earth orbit spacecraft down like flies caught in molasses. In 2003, a far weaker solar flare disabled 34 satellites in a single day, including Japan's $400 million Martian probe. A Carrington-sized event could wipe out hundreds, silencing weather monitors, military reconnaissance, and the internet backbone that keeps the modern world connected. The scariest part, we're overdue. Solar storms of this magnitude strike Earth roughly once every 500 years, but lesser, yet still devastating events occur far more often. In 1989, a geomagnetic storm, a tenth as powerful as the Carrington event, blacked out Quebec in 90 seconds, leaving millions without power during a freezing Canadian winter. In 2012, a Carrington-class ejection missed Earth by just 9 days, a cosmic near-miss no one realized until years later, when satellites studying the Sun's far side reconstructed its trajectory. Yet for all their destructive potential, solar flares also reveal the Sun's extraordinary dynamism. These eruptions stem from twisted magnetic field lines snapping like overstretched rubber bands, releasing energy equivalent to 10 million volcanic eruptions in seconds. They're a reminder that our star isn't just a lifeless ball of gas, it's a living, breathing engine of plasma, with moods and tempers as unpredictable as any earthly weather. The question isn't if another Carrington event will hit, but when. And unlike asteroids or rogue planets, we can't deflect this threat. Our only defense is vigilance, monitoring the Sun's tantrums with fleets of satellites, hardening power grids against electromagnetic surges, and preparing for the day when the sky turns red, not with dawn but with warning. Because when the Sun next unleashes its fury, the lights won't just flicker. They might not come back on at all. Supernovae are the universe's ultimate suicide bombers, dying stars that tear themselves apart with such violence they outshine entire galaxies for weeks. These explosions aren't just spectacular light shows, they're annihilation events capable of sterilizing planets light years away with a lethal cocktail of radiation, shockwaves, and shrapnel. And Earth, we've dodged this cosmic bullet before barely. Take the Vela supernova remnant, a ghostly wreckage of stellar debris spinning through space just 800 light-years away. 11,000 years ago, when humans were first domesticating wheat and building permanent settlements, this star's death scream reached Earth. Its gamma ray burst likely punched through our atmosphere, leaving traces of radioactive iron-60 in ocean sediments and Antarctic ice, a smoking gun still detectable today. Had it been any closer, say, within 50 light-years, the results would have been apocalyptic. The initial blast of X-rays and gamma rays would have ripped through the ozone layer like tissue paper, exposing every living thing to deadly ultraviolet radiation. Superheated plasma ejecta, traveling at 1/10 the speed of light, would have followed centuries later, bombarding the solar system with enough energy to trigger climate collapse. But Vela wasn't our only close call. Around 2.5 million years ago, another supernova, possibly multiple, detonated just 160 light-years away, near what's now the Scorpius-Centaurus stellar association. Geological records show another spike in iron-60 from this period, coinciding with a minor extinction event and a prolonged global cooling. The timing might be no accident. Some researchers theorize these stellar explosions could have altered Earth's climate by ionizing the atmosphere, seeding dense cloud cover that reflected sunlight back into space. Entire ecosystems may have collapsed under the double blow of radiation and sudden ice age conditions, all because a distant star decided to die. What makes supernova especially terrifying is their indiscriminate reach. Unlike black holes or rogue planets, which target individual solar systems, a supernova's kill zone spans a sphere 50 light-years wide. Within that radius, the radiation dose would be equivalent to standing next to Chernobyl's reactor core during its meltdown, instantly lethal to most complex life. Even at the outer edges of this death bubble, the cosmic fallout would still trigger mass extinctions, mutagenic damage, and centuries of climate chaos. Yet for all their destructive power, supernova are also cosmic alchemists. Every atom in your body heavier than iron, the gold in your jewelry, the iodine in your thyroid, the uranium deep in Earth's crust was forged in these explosions. They're the universe's recycling plants, scattering the ingredients for new stars, planets, and life across the galaxy. Without supernova, Earth would lack the heavy elements needed for mountains, oceans, or even the very cells that make up your body. The chilling reality is that another close-range supernova is inevitable. Betelgeuse, the red giant in Orion's shoulder, could go supernova any day in the next 100,000 years, close enough to shine as bright as the full moon for months, but thankfully too far to cause earthly harm. Other candidates, like the Wolf-Rayet star WR104, are wild cards, their alignment uncertain. One thing's clear: when the next nearby star dies, we won't get a warning. Just a sudden flash in the sky, and the uneasy knowledge that the universe has once again reminded us how small and fragile we really are. Galaxies aren't the isolated islands we once imagined. They're more like celestial wrecking balls, destined to collide, merge, and reshape the cosmos in a slow-motion dance lasting billions of years. Right now, the Milky Way is on a collision course with its nearest neighbor, the Andromeda Galaxy, barreling toward us at 250,000 miles per hour. In 4 billion years, these two titans will meet, their spiral arms tangling like whirlpools stirred together, triggering one of the most spectacular events in our local universe. But don't pack your intergalactic survival kit just yet. This isn't some apocalyptic crash, it's a drawn-out cosmic ballet where stars, planets, and solar systems waltz through the chaos, often without ever touching. The collision itself will be strangely beautiful. From Earth's perspective, assuming humanity is still around, the night sky will transform over millennia. At first, Andromeda will grow from a faint smudge to a brilliant streak across the heavens. Then, as the galaxies interweave, new constellations will blaze to life, forged from stars flung between them. Gravity will stretch both galaxies into long, luminous tidal tails, like strands of cosmic taffy pulled apart. For 1 billion years, the sky will burn with the light of 1 trillion stars caught in this gravitational tug of war. But here's where things get unpredictable. While direct stellar collisions are vanishingly rare thanks to the vast distances between stars, the gravitational turmoil could send our solar system spiraling into uncharted territory. Simulations suggest a 12% chance we'll be ejected entirely, flung into the frigid void between galaxies like a pebble from a slingshot. Drifting beyond the Milky Way's protective disk, we'd lose the dense starscape of our galactic home, left to wander a darkness so profound, Andromeda itself would shrink to a faint dot in the sky. Other models predict we might be catapulted closer to the merged galaxy's new core, where radiation from the supermassive black hole duo could bathe our planet in lethal X-rays. The irony: even in this chaos, life might survive. Planets orbit stars, not galaxies, so Earth would continue circling the Sun, as always, just in a far lonelier neighborhood. The real danger isn't the collision itself, but the aftermath. With no nearby supernova to replenish heavy elements or molecular clouds to birth new stars, any civilization still clinging to existence would face an eventual energy crisis as the last stars flicker out. Resources would become finite in a way we can't fathom today, yet galactic mergers aren't just destructive, they're also cosmic renewal. The smash-up will trigger a firestorm of star formation as gas clouds collide and compress, birthing millions of new suns. The resulting hybrid galaxy, dubbed Milkdromeda by astronomers, will likely be a featureless elliptical blob, its elegant spiral arms erased by the violence. But within that chaos, new possibilities emerge. Collisions like these are why we exist at all. The early universe had tiny, pristine galaxies, and only through repeated mergers did giants like the Milky Way form, gathering enough heavy elements to forge planets and life. So while we won't be around to witness this cosmic spectacle, it's a reminder that the universe never stands still. Even the mightiest structures are temporary, destined to reshape and reinvent themselves over eons. The Milky Way as we know it, with its familiar spiral arms, its halo of dark matter, its place in the local group, is just a snapshot in time. 4 billion years from now, it'll be gone, replaced by something new, something stranger. And somewhere in that chaos, our solar system will either find a new home or become a castaway in the dark. The universe doesn't do permanence, it only does change. Cosmic strings are relics of the universe's birth, hypothetical cracks in spacetime itself, forged in the unimaginable chaos of the first moments after the Big Bang. Picture the infant cosmos cooling from a state of perfect symmetry, its fundamental forces peeling apart like layers of an onion. In that transition, spacetime might have fractured, leaving behind ultra-dense, infinitely thin filaments of pure energy stretching across the entire observable universe. These aren't physical strings you could touch or cut. They're flaws in the very fabric of reality, narrower than a proton, but with the mass of a mountain range packed into every inch, gravity warped so intensely around them that light itself bends in their presence. The true horror of cosmic strings lies in their potential to snap. Under certain conditions, these spacetime defects could develop kinks or vibrating loops, releasing bursts of gravitational waves with the energy of a million supernovae. The shockwaves from such an event wouldn't just ripple through space, they'd potentially carve new black holes into existence or distort entire galaxies like reflections in a funhouse mirror. A string passing through Earth would slice our planet with surgical precision, its gravitational shear forces compressing matter on one side while stretching it on the other, creating twin earthquakes along a perfectly straight fault line that defies all tectonic logic. What makes these theoretical objects so unsettling is their invisibility. Unlike black holes or neutron stars, cosmic strings wouldn't necessarily emit light or radiation. We might only detect one by its gravitational lensing effect, anomalously duplicated images of distant galaxies appearing in a straight line across the sky. Or worse, we might not notice at all until it was too late. Some theories suggest certain gamma-ray bursts could be the death throes of vibrating string loops, their final moments unleashing enough energy to sterilize whole sectors of the galaxy. Yet for all their destructive potential, cosmic strings could also hold clues to the universe's deepest mysteries. Their existence would validate aspects of string theory and quantum gravity, bridging the gap between relativity and particle physics. Some cosmologists speculate networks of these strings might even seed the large-scale structure of the cosmos, their gravitational influence guiding the formation of galaxy clusters in the early universe. It's a haunting thought that the same defects capable of unraveling spacetime might also have woven the cosmic web we call home. The irony is poetic. We spend so much time fearing black holes and rogue stars, yet the universe's most dangerous objects might be the ones we can't see, defects frozen into reality during its first trillionth of a second, waiting to vibrate, snap, or unravel without warning. Whether they are out there or not remains one of cosmology's great unanswered questions. But if they are, they're a reminder that the universe doesn't just harbor danger in its present form. Some threats were baked into existence at the very beginning, silent and patient, vibrating to a rhythm older than time itself. False vacuum collapse isn't just the end of the world, it's the end of physics itself. Picture the universe as a precarious ledge, balanced on an unstable quantum field that thinks it's in the lowest possible energy state but isn't. This false vacuum is a cosmic illusion, a temporary mirage of stability masking a deeper, truer emptiness beneath. And if somewhere, somehow, a single quantum fluctuation nudges the field over the edge, the fallout would make black holes look like firecrackers. The moment the collapse begins, a bubble of true vacuum would form, not the kind you blow with soap, but a sphere of rewritten reality where the fundamental constants of nature no longer apply. Atoms gone, light redefined, the very concept of matter as we know it erased in an instant. This bubble wouldn't politely ask permission to expand. It would surge outward at the speed of light, annihilating the old universe as it grew. By the time you registered the first flicker of distortion in distant starlight, the wave would already be upon you. There'd be no time to scream, no moment of realization, just an unfathomable rewrite of existence, leaving behind a new universe with rules so alien, life as we understand it might be impossible. Here's the cruel twist. This isn't some localized disaster like a supernova or asteroid impact. A false vacuum collapse wouldn't just destroy Earth or the Milky Way, it would unmake everything. Every star, every galaxy, every particle in the observable universe would vanish into the new regime's unforgiving physics. The scale of annihilation is so total, even the concept of distance might not survive the transition. Scientists debate whether this is even possible. The Higgs field, the quantum backdrop that gives particles mass, appears stable for now, with experiments suggesting we're safely nestled in a true vacuum. But physics has been wrong before. In 2012, the discovery of the Higgs boson revealed its mass was alarmingly light, hovering near the edge of metastability. Some theories suggest the universe might be barely stable, like a pencil balanced on its tip for billions of years, waiting for the slightest nudge to topple. Others argue exotic phenomena like ultra-high-energy cosmic rays or microscopic black holes could trigger collapse artificially. Yet for all its terror, false vacuum collapse remains the most speculative doomsday scenario on the table. No known process in nature would realistically trigger it, and even if it happened, we'd never see it coming. But that's the paradox of existential risks. The ones we can't predict are the ones we can't prepare for. In a strange way, it's almost comforting. If the universe decides to rewrite itself tomorrow, there's nothing to fear because there'd be no you left to mourn what was lost. The ultimate cosmic reset button isn't just deadly, it's indifferent. So while we fret over asteroids and solar flares, false vacuum collapse lingers in the equations, a reminder that the universe's foundations might be shakier than they appear. Not a threat to lose sleep over, but a humbling glimpse into how fragile reality might truly be, and how little control we have over the deepest rules of the game. From the all-consuming maw of black holes to the silent, creeping dread of vacuum decay, we've journeyed through the universe's deadliest spectacles, forces so vast they dwarf human comprehension. These aren't just threats, they're cosmic reminders of how small we truly are in a cosmos that operates on scales of energy and time we can barely grasp. Neutron stars spin with the weight of a sun compressed into a city. Gamma-ray bursts scream across the void with the power of 1 trillion nuclear detonations, and rogue planets drift like ghosts, waiting to upend the delicate balance of solar systems. And yet, here we are, a flicker of consciousness on a pale blue dot, daring to unravel these mysteries. What's remarkable isn't just the universe's capacity for destruction, but humanity's refusal to look away. We've built telescopes to track asteroids, modeled the chaotic hearts of quasars, and sent probes into the sun's corona, all to understand the forces that could erase us in an instant. That's the paradox of our existence. We're fragile, yes, but also relentless. We've weathered supernovas' radioactive fallout, solar storms that could have plunged us into darkness, and the ever-present threat of rocks falling from the sky. Every near miss, every close call is a testament to our improbable survival in a universe that's anything but hospitable. So as we stare into the abyss, let's not just shudder, let's marvel. Marvel that we've decoded the whispers of dying stars, that we've mapped the invisible tendrils of dark matter, that we've even dared to ponder the end of reality itself. The universe may be indifferent, but we're not. We're the ones who care, who fear, who keep searching, and that's something no cosmic catastrophe can take away. Now it's your turn. Which of these celestial terrors sent a chill down your spine? Was it the silent hunger of primordial black holes, or the thought of a solar storm frying the grid? Drop your pick in the comments, and if you've made it this far, you're clearly as obsessed with the universe's dark side as we are. Don't forget to subscribe for more deep dives into the mysteries that keep us awake at night. The cosmos isn't done surprising us, and neither are we.